Good people, welcome to JJ Tech Tutoring. To this video, I'll be starting a very new series of first order ordinary differential equations. So I'm going to be uploading all the first order differential equations to this series. So the first one, I'm going to start with linear differential equation. Then from there, I'm going to go to binary, I'm going to go to homogeneous, I'm going to go to exact, and also I will do applications. So just follow up, and then don't forget to subscribe and hit the bell icon so that you can follow the series if ever you're going to be taking the math that is having first order ordinary differential equations, right? So if you're going to be working with this kind of a thing, then you have to follow this channel, and also make sure that you keep an eye on your on this series, because I'm gonna upload each and every step, each and every content that is something to do with first order ordinary differential equations. So the first one, I'm gonna talk about the linear differential equations. Right now, as said, a linear equation is the dependent variable of y. So what you have to know is that the standard form of this is just dy over dx plus py is equals to q. Right now, first and foremost, you will have to know that your p and q are constant, right? Are constant, right? And then if they are not constant, they should be the functions of x, right? So why do they have to be the function of x and not y? We are respecting x, right? So they always have to be the function of x. So dy over dx plus py is equals to q. So this is the standard form. Now this is the step number one. Step number one, you have to make sure that whatever equation that is given, it is in the standard form of linear differential equation, right? This is step number one. Step one, right? Now step number two, you need to make sure that you find the integrated factor. You have to find integrating factor, right? You have to find integrating factor, which is right. Then you have to integrate this, right? You have to integrate the p. You have to integrate the given p, right? Then from there, you go to step number three, last step. You have to write the general solution. You have to write the general solution. General solution is just y multiplied by integrating factor is equals to integral of q multiplied by integrating factor. Then you integrate this. Then from there, you are done. You can just make y subject of the formula. Then you are done, right? Or maybe we can just talk about the justification of step 3, which you can just make this subject of the formula, and it will be integrating factor, right? So that's how it is. That's how it is. Then from there, you will be done. Remember, you need to integrate this, right? Now let us do the example so that you will understand. Let us do the example so that you will be able to understand what we are talking about. Right. So we'll start with the simple example. Then from there, we do a little bit tougher example. Then I will give you the classwork, right? So that you will leave it in a comment section, or you will tell me if you got it or if you didn't get it. Right. Now, example. Right. Now, dy over dx minus y is equals to e to the power x. Right. So what you need to know now here is that you have to find p and q, right? So now your p is -1 because it's the constant. Don't forget that the standard form is something like this. So if the standard form is something like this, the y should be there, right? If the y is there, so y is multiplied by the constant or the function of x. Now this is not the function of x, but it's just constant, right? So we have to assume that it is respecting x, or we are going to integrate it with respect to x, because don't forget that your p is the one that is going to be used to find the integrating factor. Right. Now, this is your P of x, or it can be P, right? And then your Q is just e to the power x, because you know very well that our standard form is dy over dx plus py is equals to q, right? So our P is -1, right? Now, we have to find our integrating factor, which is e to the power p dx, right? Now, e to the power, what is our P? Our P is -1 dx. We can just say negative, then 1 dx. Then e to the power x is our solution, right? Because the integration of 1 is x. Then don't forget this. So it's going to multiply throughout. So it will be e to the power -x, right? Now, our integrating factor is e to the power -x. Excellent, right? Now, we have to go to, this is finding integrating factor is step number 2. Now, step number 3 is to write the general solution, right? So writing the general solution is just y multiplied by p of x, which is integrating factor, right? P of x is integrating factor, or since I introduced integrating factor as if, so I have to say y is equals to if is equals to integral of if, then q dx. So what is our q? Our q is e to the power x. What is our integration factor? Our integration factor is e to the power -x, right? So we are integrating that. Integrating factor, then y, then dx, right? Now, y is equals to, y multiplied by integrating factor is equals to, integrating factor, we have to add the exponents. So -x plus x is 0 dx. Then y multiplied by is equals to, now this is just 1. Anything to the power 0 is 1. So 1 dx. So we have to derive now. We have to integrate. So it's just y. Then the integration of 1 is x plus c, right? Then we have to make y subject with the formula. So it will be just, right. Now, this is our solution. Right? Now, obviously, we have to make sure that we do a second example. We have to do the second example. Then from the second example, we have to give each other a classwork so that you will come, you will write it on your comment section, or you will tell me if you got it. If you didn't get it, then I will do it before I do the following video or in the series. Now, another challenging example is dy dx plus y tan x is equals to sine x, right? So with this, we just have to find our p and q first, right? So now our p is tan x. Why is it tan x? Because we said if it's not constant, then it should be the function of x. It should be the function of x. It can never be the function of y, right? It can never be the function of y, right? It can never be something that is respecting y, right? So you always have to take something that is composed, or that is the constant or the function of y. Now, what is our q? Our q is just this, because it's the function of x, right? And you also have to know that knowing linear differential equation will help you to be able to maneuver around the binary, because if you don't know linear differential equation, you won't be able to deal with binary, right? So it is very much important to pay more attention in the linear, right? Now, we have to find integration factor, which is integration factor is equals to e to the power, right? So we go into tan x right now. All right. Now we have to find the integration of tan x. So now the integration of tan x is just integration of tan x is just negative cos x, right? Is negative cos x, right? Now, obviously, I will upload the video that is explaining how did we get here, but you need to just use your table to understand the integration of tan x. But if you now want to understand how do we find the negative ln of cos x, then I will do it. But you just have to use u substitution using changing this into sin x divided by cos x. Then you use u substitution, you say let u is equals to cos x, then you derive the cos x, then it will give you sin, and from there you cancel out, then it will give you ln of u. Then you come back and say, okay, u is equals to cos x, then you say negative ln cos x, right? Simple. Now from there you have to continue here now. So here you have to say, okay, ln of 1 over cos x, right? Ln over 1 over x. You take this side, so it will be ln 1 over, because when you take this, it's going to be the exponent of cos x, so it's going to be cos x to the power negative 1. So cos x to the power negative 1 is equals to 1 over cos x, right? And then 1 over cos x is equals to what? It's equals to sec x, right? This is maths, right? This is grade 11, you know. Right, now integrating factor is equals to, let us just take it as it is first, so that we understand what we are doing. Right, now you have to say change this into sec x, right? Then from there you just have to understand the logs. I will put it on the comment section, the link to understand how do we go about the sec x, right? How do we go about the log, because there is a video that I was explaining the logarithm. So introduction of logarithms, right? So you will understand the rules that I'm going to use here, right? This is exactly the same with e as a base, log base e, then sec x, right? So base and base, they should give us this, right? So the answer of this is just sec x, right? So now our solution integrating factor is sec x, because ln of something is the same with log base e sec x. So that means we have two bases that are the same, then you have to take sec x, right? Exactly. Easy. Brilliant. Now this is our integrating factor. This is our integrating factor. So now we have to go to the general solution. We have to say integrating factor multiplied by y is equals to integrating factor multiplied by what? Multiplied by q dx, right? Then from the integrating factor is sec x. Then y is equals to integration factor sec x. Then what is our q? Our q is sin x, right? dx, right? We must not be too fast. When we have a question like this, we must not be, relax a bit, breathe, take a deep breath and understand. So now here we have to integrate this, right? So first thing first, let us play with maths. Let us play with maths. We must not be fast. Let us change this now. It will be 1 cos x, right? Then sin x dx. Now what do we have now? Sec x, y is equals to, what's this? This is just sin x over cos x dx, right? So now that means the integration of tan is going to be used here now, because this is tan, but we can just leave it as it is, and then we do our u substitution and we get the answer. So here the answer of this is just going to be negative ln of cos x plus c, right? Negative ln of x cos x plus c. Now we have to change this into 1 over cos x, right? Then y is equals to negative cos x plus c, right? So final answer, y is equals to negative cos x ln cos x plus cos x multiplied by c, right? Because we took this and multiplied by it throughout here, so we have to expand it into this multiplied by this and this multiplied by this, then we are done. Then we are done, right? So now examples, or the homework is dy over dx minus 2y is equals to x plus 1, right? Then 2 x dy over dx minus y is equals to x cubed cos x. Right? First thing first here, the hint. You have to put it in a standard form first. Put it in a standard form. The standard form is dy over dx plus p, y is equals to q. So put this in a standard form. Do the dividing, do anything that will leave you in a standard form, right? You can divide throughout by x, throughout by x, throughout by x. Then you will end up having dy over dx minus 1 over xy is equals to x squared cos x, right? Isn't this the same with the standard form, right? So I gave you the hint because I just like you, and from there you just have to go and solve your stuff. But more importantly, do put it in a standard form. Don't forget to subscribe and hit the bell icon so that you can also check the whole series. I'm going to make sure that I do as many videos as possible. So make sure that you follow the series, and then it will help you to understand the differential ordinary equations. Thank you.